Now let's look at question 2. The question reads, reaction of bromine in dichloromethane with compound A, treated butyl hexane, forms a monobrominated product B. Reaction of compound C, treated butyl hextreene with the same reagent, produces compound D. Question A. Draw the structural formulae of compounds A and C. So A is treated butyl hexane. We will start with the parent chain of hexane of 6 carbon atoms, and on carbon number 3 we add a third butyl, which is a substituent of 4 carbon atoms, that is tertiary. This is the structure of compound A, and this is the structure of compound C. Compound C has a carbon-carbon double bond on carbon number 3, which also contains the substituent group. Question 2b. You are asked to identify which of the compounds in 2A exhibits chirality, and then we are asked to draw a pair of enantiomers using 3-dimensional structure for the compound. A compound exhibits chirality if it contains at least one chiral carbon, which is a carbon atom that is bonded to 4 different atoms or groups of atoms. So if we start with structure A, this carbon is bonded to 3 hydrogen. So this carbon is not a chiral carbon, also not a chiral carbon. So this carbon is bonded to 1, 2, 3, and 4 different groups of atoms. This is also not a chiral carbon, not chiral carbon, not chiral carbon, and there are no chiral carbons in compound C. So this will be the chiral carbon. Drawing a pair of enantiomers using 3-dimensional structure means drawing a dash and wedge structure. Make sure that the chiral carbon is bonded to the right carbon atom. So all the 4 groups of atoms are bonded to the right atom. So this is this group, CH2CH3. The ethyl group is this group. The third butyl group is this group, and it is also bonded to 1 hydrogen atom. 2C, we are asked to state the type of reaction involved in the formation of B and D. Compound A, which is an alkene, forms a monobrominated product B, meaning that the type of reaction must be a free radical substitution reaction, and compound C, which is an alkene with a carbon-carbon double bond, reacts with the same reagent. So because C is an alkene, it undergoes electrophilic addition reaction. Alkene A undergoes substitution reaction because it is a saturated compound, and free radical because it is made up of non-polar bond which undergoes homolytic cleavage to form free radicals. Alkenes is a carbon-carbon double bond, a nucleophilic site. A carbon-carbon double bond is an unsaturated compound. It undergoes addition. Because it is a nucleophilic site, it will react with an electrophile. Therefore, it undergoes electrophilic addition reaction. For question 2D, we are asked to draw the structures of B and D. So B comes from the monobromination of compound A, and D comes from the bromination of compound C. A monobrominated product means that only one bromine has been substituted. So one of the hydrogen atoms in compound A will be replaced by a bromine atom. Reaction with bromine produces major and minor products when possible. So we will replace this hydrogen with the bromine because this carbon will produce a relatively stable tertiary free radical as the intermediate. This is compound B, a haloalkene with one bromine atom. Reaction of compound B with bromine will involve the addition of two bromine atoms on each carbon of the carbon-carbon double bond. So this is compound D, and this is the structure of B. Remember to label the compounds. Question E, we are asked to write the mechanism for the initiation and propagation steps for the formation of B. The initiation step will involve bromine molecules in the presence of UV. Bromine molecules will undergo homolytic cleavage. One electron of the bromine-bromine bond is given to each of the bromine atoms to form bromine free radicals. A bromine atom with one unpaired electron. The second step, which is the propagation step, consists of two steps. It involves the alkene, which is compound A, to react with the bromine free radical. One electron will come from the bromine free radical to form a bond with the hydrogen, and the other electron of the carbon-hydrogen bond is given to carbon to form a free radical on the carbon atom. We are using the carbon atom that will form the tertiary free radical. So this is the free radical that has been formed, and this is the HBr from this hydrogen and this bromine free radical. The second step of the propagation step involves the free radical that has been formed in this step and bromine molecules. One electron will come from the free radical and one electron will come from the bromine-bromine bond, and the other electron of the bromine-bromine bond is given to the other bromine atom. This step produces the product compound C and a bromine free radical. For question 2F, we are asked to suggest a chemical test to distinguish between A and C, state the observations, and write the chemical equation involved. This is the structure of compound A and compound C. One of the tests that we can use is called Bayes test, which is reaction with cool basic potassium permanganate aqueous solution. The observation for compound A is the purple KMnO4 solution remains unchanged. While for compound C, purple KMnO4 solution decolorized and brown precipitate forms. So the chemical equation will involve compound C and the reagent. Compound C will react with potassium permanganate solution, basic OH minus, without the presence of heat to form diols, where each of the carbon atoms of the carbon-carbon double bond receives an OH group, and it also forms MnO2, which is the brown precipitate in the observation.